Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are a student preparing for competitive exams like JEE, NEET, and entrance test, or simply want to build strong command over chemistry concepts, then you are just in the right place. So without ado, let's get started. So today we are going to do the second law of chemical composition, that is law of constant proportion or definite proportion. This law was actually given by Joseph Proust in 1799. This law states that in a chemical compound, okay, whenever we are talking about a chemical compound, the chemical compound is made up of elements. We know that, or we can say they are made up of atoms of elements. These elements are going to be present in that compound. Compound means there are two or more elements. Okay, so suppose X and Y are there. Okay, and these elements, X is an element and Y is an element. These elements, these atoms are always present in fixed ratio by mass. There is a fixed ratio for each chemical compound. Let's take an example. For example, there is H2O. H2O is water. It is a chemical compound. Dihydrogen monoxide. Okay. So in this, there are elements, different elements, which is hydrogen and oxygen. So what we have to do, we have to see that how much hydrogen and oxygen is present by mass in air. So here two hydrogen atoms are present and oxygen is only one atom. So let's take their weight. One hydrogen atom, it has a weight of approximately 1. So 2 will have 2 unit. Okay, this is the mass we are talking about. Oxygen has 16 unit. Okay, so we are talking about the ratios. Let's take and convert them into ratios. So hydrogen ratio oxygen, okay, we are going to take ratios of masses. Okay, so ratios are hydrogen is 2 and oxygen is 16. Now these ratios they have common factor. They can be converted into simple ratios. So how can we convert? These have common factors 2. Okay, so it becomes 1 and it becomes 8. So hydrogen is to oxygen in water is present in 1:8 by mass. So whenever there is a water, okay, we are talking about water. So in this, the hydrogen and oxygen are always present in 1:8 by mass. This can be done for other chemicals also, like take carbon dioxide for example. Okay, right? There are carbon and oxygen. There is one atom of carbon and two atoms of oxygen. One atom of carbon has mass, it weighs 12, and oxygen weighs, one oxygen weighs 16, so 2 weighs 2 into 16, that is 32. So let's take their ratio. Carbon is to oxygen is 12 is to 32. Once again, these are even numbers, so we have the common factor in them. Okay, we can take that. First is 2 becomes 6 and 16. 6 and 16 came. Once again, these are even numbers, so they have common factors 3 and 8. So in carbon dioxide, carbon and oxygen are present 3:8 by mass. Okay, so this is called law of constant proportion or law of definite proportion. So there are some limitations of this law, actually you should know. Limitations of this law of constant proportion. What are the limitations? First limitation is that there are isotopes. Okay, and isotopes are same atom, same atoms, but different masses. Okay, let's take an example like carbon. Carbon has majorly two isotopes. Okay, so what is the isotope number 1? Isotope number 1 is carbon 12. It has mass of 12. Okay, and there is another isotope, that is carbon 14. It has mass of 14, right? If we talk about these, then if we take carbon dioxide, suppose we take carbon dioxide, and there is a carbon dioxide with carbon 12 is to 32. Okay, we are talking about carbon dioxide, so its ratio becomes 3:8. This is the actually simplest whole number ratio. Okay, we are talking about simplest whole number ratio. Right, but if we take a carbon dioxide with carbon 14, then 14 is to 32. Okay, then over here the ratio becomes 7:16. Now this ratio is entirely different from the ratio, and it cannot be done, right? Carbon dioxide should not be like this, but it may happen. So this is the first limitation. All right, the second limitation, let's talk about the second limitation. Okay, we know that according to this law, the atoms should combine in constant proportion. Okay, suppose they are combining in constant proportion, but they will have the different compounds. Okay, the atoms they combining in constant proportion. Okay, they are combining in constant proportion, but it will lead to different atoms, compounds. They will make different compounds. How is that possible? Okay, suppose we are taking like C2H5OH, right? It has an isomer of CH3OCH3. What are these? This is ethanol. Okay, and this one is methyl ether, or you can say methoxymethane. both have 2 carbons, 6 hydrogens in common and 1 oxygen, but both are different. If we take carbon is to hydrogen is to oxygen ratio, okay, there are 2 carbons, so 24 is to 6 hydrogen, 6 is to 1 oxygen, 16, and we take the simplest whole number ratio, okay, it becomes 12 is to 3 is to 8. So this is the whole number ratio which is simplest, okay. So this is how they are present in both of them. Remember, they are present in both of them. This is the same ratio for ethanol also, same ratio for methoxymethane also, okay. But once again, this is a limitation because it is giving 2 different compounds. Okay, let's talk about the third law. Law of multiple proportion. It was actually given by Dalton in 1803. Okay, this is actually similar as definite proportion. This says that there are suppose two elements. Okay, suppose there is element X and Y. Okay, they can combine in different ratios. Suppose they are combining in ratio 1. They will form a compound 1. Okay, if they are combining in another ratio, the ratio is different, and once again we are talking about ratio by mass, so they will form the compound 2. Both these compounds are different, but their ratios are also different, and elements are same. Okay, they are same. Okay, we can take a lot of examples in them, like we can take water once again. Okay, air, hydrogen and oxygen are in ratio 1:8. Okay, but hydrogen and oxygen also form hydrogen peroxide. This is entirely different substance. Okay, entirely different composition, entirely different reactions, entirely different properties, right? And over here same elements are present, but their ratios are different. Here it is 1:16. The ratios are different, right? The compound form is different, but elements are same. So there are few things you have to remember in this. The elements are going to be same, compound is different, and ratios are also different. Okay, what are these? These are compounds, these are elements, and these are the ratios by mass. Okay, as you can say, what is different, what is same. So this is known as law of multiple proportion. That means same elements can combine in different ratios to form different compounds. Okay, they can combine in multiple ratios actually. Okay, that's why the name multiple proportion. They're combining in multiple ratios. It is not the same with this one also. There are other examples too. Let's take carbon dioxide. There is carbon monoxide also, right? Carbon dioxide has a ratio of 3:8. And in carbon monoxide, it is going to be 3:4. Carbon and oxygen are same, right? Elements are same, but they are combining in different proportions, or you can say multiple proportions, to form different compounds. So there are a lot of examples about it. Fine. So this law is called law of multiple proportion. There is the very best example of law of multiple proportion, that is uh, elements formed by compounds formed by nitrogen and oxygen. Okay, so nitrogen and oxygen, when they combine, they form different compounds like N2O, nitrous oxide, which is also laughing gas, nitric oxide, nitrogen dioxide, N2O3, N2O5, which is nitrogen pentoxide, nitrogen trioxide, and nitrogen pentoxide. So these are the different, over here the nitrogen and oxygen are present in variable ratios, and they are forming so many different oxides of nitrogen. Okay, so you can calculate the ratios over here. I am giving this homework to you people, so go and calculate the ratios by mass. I will give you the ratio masses of these nitrogen and oxygen. Mass of one nitrogen atom is 14, and mass of one oxygen atom is 16. Okay, go take these and calculate the ratios. This is your homework. Okay, fine. And please comment in the chat box also that what are the different ratios of these all oxides of nitrogen. So next one is law of reciprocal proportions or alternate proportions. Okay, it was given by Richter, 1792. So according to this law, Richter told us that if suppose there are three elements like X, Y, and Z, both X and Y, they combine in fixed ratio by mass with each other to form a compound. Okay, X and Z also combine with each other to form a compound. So Y and Z can also combine with each other to form another compound. This is called reciprocal proportion. Let's take and understand it with some example. Suppose we are taking hydrogen, oxygen, and sulfur. Okay, let's take this example. So when we talk about hydrogen and oxygen, we have done it already, so let's take that example. When hydrogen and oxygen combines with each other in 1:8, they form water. Okay, when hydrogen and sulfur we are taking, okay, so we are taking their ratio 1:16. Okay, and they are forming H2S, which is hydrogen sulfide. But when we are talking about sulfur and oxygen, they also combine with each other, okay, in 1:1 ratio, and they are forming sulfur dioxide. Okay, as you can see, these are the different ratios of different elements. They are combining with each other and forming different substances. So this is the law of reciprocal proportion. Let's do the fifth law. Fifth law is Gay-Lussac's law of combining volumes. This is for gases actually. You should know that. This is for gases. When gases combine with each other, what happens with their volumes? So it was given by, as the name suggests, it was given by Gay-Lussac. Gay-Lussac. He was a scientist. He gave it in 1808. He proposed this law in 1808. So it states that suppose we are taking two chemically combining gases, okay. Remember, those gases will be chemically combining, means they will do the chemical reactions, okay. Chemical combining gases are there. When we are mixing them with each other, remember, we are mixing them at this is provided that they have to be taken at constant pressure and temperature. The condition should be constant, okay. So when they are chemically combining, these two gases are combined in ratio. Suppose there is a gas A and we are taking one volume of it. One volume can be anything, 1 milliliter, 1 liter, okay, in the ratio. When it is combined with a gas B, okay, it becomes it. Let's say we are also taken one volume, and when we have combined them, there is a formation of a mixture AB, okay. Suppose it has two volumes. Their ratios of the volumes, okay, should be simple ratio by volume, simple whole number ratios by volume, not by mass. Now we are talking about volumes because we are talking about gases. Gases have volumes. Let's understand this with an example. Suppose we are taking H2 gas, hydrogen gas, and we have taken one volume of it. We are combining it with Cl2 gas. We have taken one volume of it. We know then when hydrogen and chlorine gas react with each other, 2 moles of HCl gas is formed. Once again, this is a gas, but its volume is 2 volume. Its stoichiometric coefficient is 2 volume. Over here, these hydrogen, chlorine and hydrogen chloride gases are in ratios 1:1:2. These are the simplest whole number ratios for it when they are chemically combining or doing the reaction. Let's take another example. Suppose we are talking about H2 as a gas we have taken, and oxygen gas we have taken, and we are making water in the vapor form. That is also gaseous form, okay. So when we are using law of chemical composition over here, the first law, which is law of conservation of mass, so we have to balance it, okay. We are balancing. Now we can see the hydrogen is taken in 2 volumes. So when 2 volumes of hydrogen combines with 1 volume of oxygen, okay, it gives actually 2 volumes of water, okay. It is not like we are not adding the volumes. They are combining, they are mixing with each other, then they are reacting with each other, and then at the end what is forming. So there is, you can see that there is inclusion of a law of conservation of mass over here also. Okay, so this is called Gay-Lussac's law of chemical combining volume. So these were the all laws which are present in the chemistry, and they are, different laws of chemical combinations. So these are followed in chemistry whenever we are doing different reactions or anything in the chemistry. So that's all for today. I hope you not only understand the concepts but also gain the confidence in solving different questions. Always remember that chemistry becomes easy when you focus on concept first and practice constantly. And that's how we'll continue doing here on Atomic Ascent. Thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.